So as the name suggests, what is root cause analysis required for? It is primarily required in two contexts. One is either you want your network to explain why it made a certain prediction, or you want to ask your network what changes do you want to make on your input so that you get a certain desired output. Now, why is this useful? This is very useful in contexts like, say, business metrics. Like you are a company, you have certain business metrics that you are tracking, and you have a lot of input parameters that can affect your outcome. And some things are going good and some things are not going good. So how do you request an automated neural network to give you an insight onto what went wrong or what went right? So you see, that is where explainability is very important. And what our auto classifiers come with is root cause analysis baked into them. So wherever you do dot predict single, instead if you just do dot explain, you're going to get detailed explanation of what parameters led to a certain prediction or what parameters could have led to a better prediction. So just to give some example, a toy example here, it's in sentiment analysis. If we were to type in a query like, I like the movie, but I wouldn't recommend it to watch. Now, most models out there can say this is a negative sentiment. That's not very hard. But saying what made that prediction, won't recommend, is hard. That is what we solve. And additionally, we also give phrases in sentiments, not just a single token, but a phrase that dominates some other phrase and results in a right prediction. So we're going to show some examples about that. Also, in case of credit analysis, for example, just like the tabular data that David discussed, what if how does a bank make a decision on whether a certain person needs to be awarded a credit or not? There are several factors that go into credit analysis, like age, education, salary, etc. Now, how does an automated system give a decision that this is approved and also say what is the reason for the approval, or what is the reason for the disapproval? So these are the scenarios where root cause analysis is very important, and all our auto classifiers come baked in with root cause analysis. So that is, we'll show a demo on how that works. So this is in the context of sentiment analysis. Let's start with a simple query. The film was good. You see, it says it's a positive sentiment, and it says was good is the phrase that was responsible. Now, this isn't very hard. This seems too simple, but let's give it a relatively complicated query where there are conflicting sentiments. The film was good, but the acting was bad. It suddenly flips the sentiment to negative, and it says there are two influential phrases, was bad and good. Both of them contribute to conflicting sentiments, but the dominant phrase was bad. See, that's how our root cause analysis module works in so much of detail. And let's again give it another query. The film was good, but I would not recommend it. Just the one in the slide. You see, would not recommend is the dominant phrase, while it counter interacts with good, but it still goes with would not recommend. So that's a very useful prediction with clear phrase detection of what causes the negative sentiment. Let's switch the context from a movie. Let's say the money is good, but the work is not. Again, we see again here, not, good, money, work, all counter interact, but the dominant phrase is not, and it gives a negative sentiment.